In this example, we're going to be graphing a transformed exponential function. But before we do that, let's take a look at the original function. So the original function was y equals 2 to the power of x. I've already gone and created a table of values for that original function, so let's graph that up here. We start with 0 and 1, 1 and 2, 2 and 4, 3 and 8. You can keep going if you want, but I am not going to do that. You want to now draw your exponential function like so. So as discussed, we know that there is a reflection. We know that it's a reflection across the x-axis. So that means you can cross this out, cross this out, cross this out, cross this out, and cross this out. So a reflection of the x-axis would impact the y-coordinates. And what you're doing to the y-coordinates is you are multiplying it by -1, basically. So I'm going to say multiply by -1. So all of that becomes -1, -2, -4, -8, and -16. My x-coordinates are going to remain the same, and my new y-coordinates are going to be these. And let's graph these coordinates now. So we're going to go all the way up here, and let's go ahead and graph that. So my first coordinate is going to be 0 and -1, 1 and -2, 2 and -4, and 3 and -8. All right. And I'm just going to go ahead and connect those like so. So that is what your transformed exponential function is going to look like. Next, let's determine its properties. So in terms of the domain, the domain is x is an element of the real numbers. That really hasn't changed. Now, in terms of the range, you'll see that because this function has been reflected across the x-axis, that means the range is going to be y has to be less than 0. There is no x-intercept, so let's just cross that out. And the y-intercept has changed. The y-intercept is right over here. It is now -1 instead of +1. So let's write that down over here. Now for the interval of increase or decrease, let's take a closer look. So you can see that as the value of x increases, the value of y decreases. So you can say that this is decreasing. All right. Now, in terms of the horizontal asymptote hasn't changed. So the original horizontal asymptote was right over here. Okay. It was y equal 0. But because the function was reflected across the x-axis, the horizontal asymptote really just remains in the same place. So you can say the horizontal asymptote is just y equals 0.